Hello and welcome to this session. This is the 13th in its series, and today we are going to discuss part 2 of trends in data warehousing. That too we are covering complex data and cloud data warehousing. So in the earlier series, that is trends in data warehousing part 1, we had covered data lakes architecture, some use cases of data lakes, data swamp, and other considerations. So in continuation with that particular part 1, this is part 2, and this session pertains to unit 6 of block 2, MCS 221, data warehousing and data mining. In today's session, we will try to cover the complex data and then the concepts pertaining to the cloud data warehousing. So we have seen how big data has become spreading widely across several enterprises. So nowadays it is not about the data management system and other kinds of things. Now we are talking about the huge lot of volumes of data coming into the enterprises. We have also seen different ways in which the data is generated, that is the structured data, the semi-structured data, and the unstructured data. Like structured data, there is no problem with that. We had already discussed in our earlier series also how to design the data warehouses for the structured data. However, the main things comes when the complex data is considered into the data warehouses. So with the scale, the speed of the data that is coming into the coming from the enterprises and is being stored. So the term complex data was coined to define all these kinds of semi-structured and then the unstructured data. That too, when the action comes to take place for the data warehouses to give some sort of visual data or else data visualizations, or else the data in the form of charts and other kinds of visual elements. So here, this particular complex data doesn't conform to some standard data types. Like earlier we had seen, say, there are several standard data types like integer, float, amount, and other kinds of data types that we have seen and which can be stored in a particular format. And this particular complex data is not that much conformity when the structured databases are being considered. So this complex data is the data that has multiple dimensions, relationships, and different various kinds of formats that cannot be easily stored, processed, or analyzed by traditional methods. So there lies the complexity. Complex data can come from various sources such as social networks, web pages, sensors, images, videos, IoT devices, natural language. So these are some of the sources wherein which the complex data is generated, and working with this particular data requires a kind of complex data modeling also. So here complex data has its intrinsic traits like its own syntax, schema, technology, terminology, and various kinds of different file formats that it would follow. So this diversity of traits, so suppose if you take the kind of a video file or else the audio input or else the images or else some streamed data from the IoT devices, so they doesn't have certain schema or certain kind uniformity in the schema, uniformity in the syntax, uniformity in the terminology or the type. So they store in a fixed formats which is defined for that. However, these can't be pulled into a kind of standardization. So this diversity of traits complicates the work of data modelers. So some models are being proposed. Those are the statistical models, polyglot model, no payload model, multi-level model, and other kinds of models in order to maintain the complex data modeling. However, there are two models which are being given in our course. Those are, one is the anchor model and second is the data vault model. So these are the prime models which are being used by the modelers in order to model the complex data. So both these models provide a kind of advantage, like it takes care of the scalability, temporal data handling, and are resilient to structural and content level changes. So let us discuss one by one. First we go to the anchor model. So anchor model has 4 elements altogether. So with these particular 4 elements, the whole model can be designed. First one is the anchors, second one is the attributes, third is called as the ties, and fourth is the knots. So anchor is nothing but the anchors are used to model the entities or else the events. Suppose if you take the case of an ER model, entity relationship model, there also you will find a term called as entity. So in that particular entity, we draw a spiral, and then wherever the attributes, wherever the properties of that entity needs to be mentioned, we draw a kind of arrow, and then we mention the property of that particular attribute. So in this same fashion, anchor also can be considered. So these particular anchors model the entities or the events. That is one element. The second element is the attributes. That is nothing but the properties of the anchors comes under the attributes. Then the third element is the ties. These ties are used to model the relationship between the anchors. In the same way, if we see the analogy of the ER diagram also, there also you will find the kind of relationships, like one-to-one relationship, one-to-n relationship between the entities, or else m-to-m relationship between the entities. So these particular things also pertains to ER modeling. The same way you can consider the tie also is a kind of element wherein which in order to model the relationship, this particular item is been considered. And the fourth one is the knot. Knots are used in the modeling of shared properties such as states and other kinds of things. So all the 3 above mentioned elements like anchors, attributes, ties are in the analogic with the ER diagram, but the knot is nothing but knots are used in the modeling of shared properties such as the states. Let us see an example given on the slide. Here you can see the anchor is mentioned in the red color square kind of thing, or else the gray color square kind of thing. And the MM here, these are called as the relationships, or else you can call them as the ties. So these are being tied with a relationship called as M2M relationship. And here you can see the circles are being mentioned over here. And that particular circle is consisting of the property surname, person's surname, or else here also you can have the person's gender. So these particular 2 circles represent the static attribute or else the historicized attribute. Let us learn the historicized attribute also, wherein which versioning is also mentioned over here. So this is the second version. You can say second round is there. So this is versionized attribute, or else you can call it as a tie, historicized tie. And then there is another thing called as the knot here. You can see the red square with a dot, and this particular thing is nothing but a knot wherein which the modeling of the shared properties are being considered. So this is a simple example wherein which the complex data can be mentioned using the anchor model. So attributes and ties can be versionized. So first version may be there, another after the improvisation, or else considering the new data into consideration, the next kind of version also can be drawn into. So this particular version maintaining the version is also called as the historization, when changes wherein which it takes care of the information after the change. So the different graphical symbols, as you had seen in the earlier diagram, represents the elements of the model, like the anchors, the attributes, the ties, and the knots. An outline of a tie or attribute depicts versioning of the changes that we had seen. A circle is drawn, the double circle, wherein which it mentions there is a kind of versionized or else historization involved in that particular thing. Then the second model is called as the data vault model. So data vault model is a database modeling technique, offering long-term storage of historical data arriving from multiple operational systems. So this model allows coping the issues such as auditing, data traceability, data loading, performance, resilience to change. So this also takes care of all these kinds of properties over here. And this is also a very popular model when compared to the other thing that we had already discussed, the anchor model. A data vault is a data modeling technique, and it is used to build data warehouse for enterprise scale analytics. So the data vault is a data model that is well suited to organizations. Those are adopting the lake house data warehouse architecture, or else lake house paradigm we can say. So data vault has three elements, namely the hubs, the links, and the satellites. So what is a hub over here? Each hub represents a core business concept. So that is the thing that you have to remember. Earlier in the anchor, what we had seen, that is called as a kind of entity or else a kind of an event. But here the hub is represented, the hub is nothing but it is a core business concept, such as they represent the customer ID, product number, vehicle identification number, or else users will use a business key to get information about a hub. The business key may have a combination of business concept ID and sequence ID, load data, and other metadata information. So this particular thing is a core element which we call them as a hub in this particular data vault model. Then comes the links. Links, the name itself says that it is a kind of relationship between the hub entities. It is a kind of link between one hub to the other hub. And the third element is the satellite. So satellites will fill the gap in answering the missing descriptive information on core business concepts. So satellites store information that belongs to hub and relationships between them. So once again we will see the satellite is nothing but it is a kind of element where it sits in the middle, and its main functionality is to fill the gap in answering the missing descriptive information on core business concept. If at all there is some missing information, it will be taken care by the satellite. The satellites store information that belongs to hub and relationships between them. So let us see one diagram over here, or else example over here, in order to understand the whole concept. Here there are three colors of rectangles given. One is blue, yellow, and then green colors are been projected over here. So in the data vault model, all the three elements are being covered. Blue colored rectangles is the identification of the hubs. So you can see there are three blue color rectangles given over here. So those particular things comes under the hubs. And there are four satellites given in represented in the yellowish color. You can see subcategory, S product subcategory, S product category, S product expanded, S product main. So these particular four yellow items are called as the four satellites, and the links over here are represented in the green, and these are the links which will be linked to one hub to the other hub. So these are the three elements which are being very much essential for modeling the data vault model in order to model the complex data. So let us see the benefits of the data vault model. One is that it is very agile in nature. It is structured with flexibility for refactoring, and this particular model is extremely scalable. Whenever there is a kind of problem, that particular descriptive kind of natures can be taken care by the satellite, as we can see. And it is extremely scalable, and it can accommodate up to petabyte volumes. So use patterns that support ETL code generation, and this is very much familiar architectures wherein which data layers, ETL, star schemas are present over here. So let us switch on to the next topic, important topic, that is the cloud data warehousing. So enterprises have to confront demands of space and location. Nowadays, nobody is concentrating upon the infrastructure that needs to be procured or else bought from outside market. So most of the organizations, enterprises, MNCs are been shifting the whole thing to the cloud platform. So for the new demands, like suppose if the organization is having certain capacity of data generation, nowadays all the organizations are producing huge volumes of data. And that too, the other thing that we have to consider is the business always expands. So some more data, more and more data are being included into the data warehouses. So new demands are being imposed by regulatory compliance mandates, data velocity, new data resource, new data sources, performance, scalability, quality of service, etc. In order to cater all these things, the primary thing that the organizations are looking for a new kind of solution. Instead of claiming, or else instead of procuring the new data infrastructure, or else data improving the data center by themselves, what they are doing is they are going for the paper utility kind of thing, that is the data warehousing kind of thing. So enterprises have realized that a data warehouse implementation is no more a silver bullet for their problems, considering the new environmental dynamics and other issues discussed above. So one thing is that always the business has been expanding. The second thing is data is pouring into. That too, nowadays, all these organizations are having a social media kind of thing and other kinds of presence on the social media. So more and more data is pouring in, and from that they wish to have some sort of analytics also. So instead of having the core infrastructure developed at their end, what they are doing is they are looking for a solution wherein which it has the scalability feature. So the basic solution that we are getting is from the cloud only. So reasons for migrating to the cloud is, one thing is you will get the instant access to all the infrastructure resources. Procuring huge amount of resources, it involves expenses or else investments from the organization, and also it is time consuming. Even though you plan today to buy the new infrastructure, it may take another 4 to 5 months to get it delivered. So it is a kind of time taking process. And if you claim, or else if you open an account with the cloud company, cloud based cloud providers, then you have to fill up the SLAs, and then you have to get the instant access to that particular resources, whatever you are claiming for. And the second thing is derive a pay of use benefit. It is nothing but pay per use. Suppose if you want more, you can scale up. If you want to less kind of infrastructure, then you can scale down automatically. So this particular scaling up and scaling down is very much possible only with the cloud data warehouses. Otherwise, scaling up in a physical data unit or else data center within the organization is very much difficult. And if at all the resources are not being used, then it will go into the waste kind of thing. So here with this particular cloud, getting the cloud accounts is very much easy, instant, and then it is also very much, the expenses will be very much in control. So enterprises are going for the best of breed applications, wherein which they are opting for the software as a service, or else we can call it as SaaS, and to their cloud implementations. Suppose if you want some sort of software to support your systems, no need of going or buying the licenses. However, this particular thing also can be taken care by the cloud provider himself or himself. So the entire business intelligence, analytics, whatever you say, they are provided in the form of a service. So most probably the cloud data warehouse as a service is another concept which is emerging today. So whichever the organization wants the data warehouse or else the kind of data warehouse kind of architecture, then they will provide adequate infrastructure along with the software and other kinds of things loaded into it. So these particular things, the main advantage is they can scale up or else scale down, as we had already discussed, with minimum installation or maintenance charges. So this is a simple figure which is depicting the kind of cloud thing that is used for SAP Data Warehouse Cloud. Here you can see supply chain. The data is coming from various sources. One is from the supply chain, one is from the CRM, third one is from the data, and here the processes are taking place, and it has been migrated. The whole data has been migrated to the SAP Data Warehouse, that is the cloud CDW. In short, we can call it as the CDW. And then later on, the kind of analytics or else the data visualization elements are at the right side end. So the advantages here we can see is it is having a kind of improved performance, that too no need of waiting for months together. It can immediately be claimed upon, and then you can use that particular cloud data warehouse with the appropriate software into it. So flexibility of cost through flexibility of cloud resources utilization. And the other thing is we have to see the return on investments also. Whenever you are putting investment, that too for a data center, that too it costs, like the storage and other kinds of things, processing, storage and other kinds of things costs heavily. So suppose if you are unable to tap that particular potential, or else return on investments, it is waste of installing that much huge infrastructure into the organizations. So it includes huge expenses also. So there you have to have a kind of idea wherein which it should be having a kind of potential on the return of investment you have to see, and then reliability feature you have to see, and then the advantage that the CDWs are having the scalability, elasticity and enhanced accessibility. So you can say you can give access to as many personals as you can through a window with certain privileges. And then the data security is when you compare to other kinds of architectures, here the CDWs have the highest data security also. So the advantages I had given it on the slide. One is the cost reduction, reliability, data security, and then scalability and enhanced accessibility to the personals. So as we have seen the advantages, there are certain challenges also with the cloud data warehouse. One is that the data extraction, how the data is being extracted and put onto the cloud, or else how the transformation procedure, the ETL procedures have to be taken care, whether it will be from the ready-made solutions, or else whether you have to build up your own solutions and you have to put it onto the cloud. Those particular things we have to see. The other thing is context and user-based data access. Whom to provide the access, whom to restrict, whom to give, what kind of privileges are need to be given to the person to whom you are providing the data access. All these things you have to take care. And the third challenge is management of heterogeneous data velocity. So data is coming from huge resources, not from one resource, one source. However, from different sources you are getting the data. So that particular velocity also you have to take care, and you have to appropriately claim for the cloud services also. Ensuring instant availability of new data sources, ensuring the data quality, management of sensitive data. As you are putting on to outside the premises of the company, so you have to take care what kind of sensitive data it is having, and then you have to take appropriate care for placing that particular sensitive data, and compliance to the regulatory mandates also. So interoperability is another issue. So then we have to see what kind of interoperability techniques are there, or APIs are there, or else the tools are available in order to operate between two clouds, or else from your data center and to the cloud, or else some sort of whenever the operations takes place at dual ways. So that thing you have to take care. Communicating with legacy systems that could not be migrated to cloud for technical and organizational resources. All the things we may not be in a position to move on to the cloud. However, sometimes we may be maintaining certain things onto our data, into our data center, and some things we have to migrate it to the cloud. Data governance and confusion of sensitive data, that needs to be sorted out. And you have to see, watch, and have to take appropriate care whenever you are placing the sensitive data onto the cloud. So how to build the successful cloud data warehouse? So there are three stages. One is that one stage is that formulating an approach for data curation at scale and data integration. And then the second thing is leveraging the data integration platform for on-demand data provisioning. And third is ensuring high quality of heterogeneous data across the CDWs. So in the stage one, there are certain considerations to make. The first consideration is preparedness for enterprise changes. So the enterprise, as the enterprise keep on growing, that data may be coming. The data may be coming from various sources. Now the sources are finite, but maybe in next few months, as the business, they may be thinking to expand. Then you have to take care what kind of additional data sources are coming, and then you have to build. You have to ask for the infrastructure also in such a way to the cloud service provider. So besides the technological changes or the ability to prepare for such scenarios, all the preparedness you have to see from the company side, and then only you put forth the kind of claim to the cloud provider. Then the second consideration in stage 1 is enterprise readiness to adopt the new technologies. There may be resistance pertaining to each and every organizations. They are accustomed to certain kind of practices over there, or else certain kind of things coming from the access coming from the data center of their own company. However, whenever there is a kind of migration, there may be a kind of resistance from the employees or resistance from the administration. So you have to see the readiness to adopt these kinds of new technologies. And then the third consideration in stage 1 is the future objectives of your enterprise. That is, you have to take care, you have to have a vision kind of thing that would have a critical impact on your data integration architecture already in place. So some data you had maintaining in the data warehouse. However, in the second thing, whenever you migrate to the cloud, then you have to see the readiness also. Then enterprises expectations. That also you have to see the adding the measurable and tangible value to its business. Otherwise, you should not go for the cloud provider if at all there is not that much heavy load onto the data center. In the cloud, in the stage 2 also, there are certain things which needs to be taken care about the vast volumes, heterogeneous characteristics of the data, and then to extract the maximum value from the data. Otherwise, it is waste of time and waste of resources. The latencies at different levels like data extraction, data storage, organization, and other kinds of things. So these are the three considerations that one has to have in the stage 2. And in the stage 3, you can have the quality kind of aspects, the ensuring the high quality, and then the cloud-based ETL tools and other kinds of ready-madely available things that needs to take care. So in this particular session, before winding up, let us recap once again. In this particular session, what we had seen the definition of the complex data, how to model the complex data. There are various models available. However, in this particular session, we had discussed two models. One is the anchor model and the other one is the data vault model. And towards the end, we had seen how the cloud data warehouses provides the services and what all the things that we have to see in stage 1, stage 2 and stage 3 of cloud data warehouses. Hope you had understood this particular session. Otherwise, you please once again read the material that is given in under Unit 6, Trends in Data Warehousing. Thanks for your patient listening. Thank you very much.